All right, so now we're going to look at an example. All right, so in this example, we have the airline market, right? Remember, we're looking at, just a quick reminder, we're looking at United and American, AAUA. Okay, so in this example, we have that the market demand, which is QD, demand function is, okay, so we have that QD is equal to 339 minus P. And we have that the marginal cost in this market is flat at $147. Right, this is also equal to the average cost in this market. Remember our assumption that this number, this marginal cost function, is the same for both American Airlines and United Airways. Okay, let's look a little bit more at this demand function. So QD here, QD is the total quantity of the two airlines combined. I'm going to measure this in thousands. Okay. And we have that price here, or P is price. It's the dollar cost of a one-way flight. One-way flight. All right. So let's use this information to figure out how many flights should be offered by American if they're maximizing profit, and how many should be offered by United if they are also maximizing profit. It's important to note that the quantity, let's just write this here, the quantity that each firm picks or chooses depends on their residual demand curve. Residual, we introduced this in the other video, demand curve. Remember, it's the demand that they are going to supply to the market. And their marginal cost. Where what we want to do is maximize profit. Right? And we know the condition for this. The condition for this is that marginal revenue is equal to marginal cost, or that the derivative of the profit function with respect to quantity should be set equal to 0. Right? And we know that profit is equal to total revenue, quick review, minus total cost. So if we take the derivative of this with respect to quantity, then we have marginal revenue, right? Because the derivative of total revenue with respect to quantity minus the derivative of total cost with respect to quantity should be set equal to 0. So we have the marginal revenue, which is the derivative of total revenue, minus marginal cost, which is the derivative of total cost with respect to quantity, will be set equal to 0. So we have that marginal revenue is equal to marginal cost. Quick explanation here of how we derive marginal revenue, marginal cost. You should have seen this in previous videos. If you haven't, feel free to go back and look. Okay, so what we want to do is figure out the marginal revenue for American and set it equal to the marginal cost for American to determine the Q star for American. And we're going to do the same thing for United. We want the marginal revenue for United, set it equal to the marginal cost for United, right? And we're going to use that to get the profit maximizing quantity for United. All right, let's go ahead and get started. All right, so if, actually, let me label what we're doing here. We are now in the residual. Let's get the residual demand for American. So if American Airlines, okay, if United Airlines flies QU, the quantity of whatever quantity they fly, then American will fly whatever is left, right? Then American Airlines will fly the remaining. So if this is the total and United already flew this many, then American is left with whatever is in the market. Okay, so we will say that quantity for American will be equal to the big market quantity, which is a function of price, right? Because price is on the right hand side of this equation. So this big quantity is a function of price minus whatever quantity that United flies. We can plug that information from above in. So we have that QA will be equal to 339 minus P minus QU. Okay, this is QA. Quick side note. This is similar for United, where QU will be equal to the market, which is a function of price, minus whatever American does. So this would be equal to 339 minus P, right, minus QA. This would be QU. Okay, just a quick side note. Let's go back to American. All right, so with this information of QA is equal to 339 minus P minus QU, American Airlines can think of itself as a monopoly for the rest of the market, of itself as a monopoly with respect to, so for the remaining of the market, the people who did not fly on United. Okay, now this should give you some good breath, right? Because you're coming from that monopoly model, you know how to do the calculation, and so you're in familiar territory. With this information, we can now, because this is the residual, Americans residual demand function. Right, residual demand function. So with that information, we can determine or calculate, well, let's say determine. We can determine American Airlines best response function to whatever quantity United does. So the best response function is whatever quantity American chooses, that's going to be dependent on the quantity United chooses. Okay, so we would say that American's choice of quantity is dependent on United's choice of quantity. And remember, we talked about in the introduction. BA here just tells us that we're looking at the best response for American. Best response for American. Okay. So we're going to use the residual demand function and marginal cost. Yes, that's right. We're looking for MR is equal to MC for American. Okay, so let's go back. Let's get this done. We have that MR. Actually, I'm going to do the calculations in blue. MR is the derivative of total revenue. MRA will be the derivative of total revenue for A. We already know that MC is equal to 147. Life is great there. We can just leave that. All right. So let's get the total revenue for American Airlines. That would be P times Q for American Airlines. Make sense? Good. Now the thing, we already know what QA is, right? QA is QA. But what we don't really know is P. All the information we have up to this point is that, let's use the old color. All the information we have up to this point, excuse me, exactly, is this, right? We have this residual demand function, right? We can copy this if it will let me. Nope. All right, that's fine. We'll just rewrite it. We have that QA is equal to 339 minus P minus QU. So we can solve for P, which would give us that P is equal to 339. So take this to the side and take this to the side. It minus QU minus QA. Okay, notice that this is equal to 339 minus QU plus QA, which is 339 minus Q, right? And that is very similar to our original demand function solving for P. Right? So it's just the same thing as saying P is equal to 339 minus Q, where Q, where Q, big Q, is QA plus QU, right? So P is equal to 339 minus QA plus QU. P is equal to 339 minus QA minus QU. If you've been watching my videos, you know at this point I always like to have checkpoints for my work. That's a great checkpoint there. Okay, so we're coming back to this. We have that P is equal to 339 minus BQ or minus QA minus QU. So we have that our total revenue for a different color, excuse me. We have that our total revenue for A is equal to 339 minus QU minus QA times QA. Okay, we can remove the parentheses, multiply through. We have 339 times QA minus QU QA minus QA squared, right? 2 QAs. Now, all we've done here is write out the total revenue for American Airlines. Notice that it is still a function of United Airlines quantity. So this really just highlights the fact that in oligopoly and especially in duopoly, the decision of one firm is highly dependent on the decision of the other. Okay, so we have our total revenue, then we can use this to calculate our marginal revenue for A, which would be equal to 339, because that goes to 1, excuse me, minus QU, because that goes to 1, minus 2 times QA, because this comes down and we subtract 1. Okay, so we have our marginal revenue for A, and we need to set this equal to, that's right, we need to set it equal to marginal costs so that we can figure out our optimal choice for American Airlines. So we have, this is our profit max condition. Okay, so we're going to have 339 minus QU minus QA is equal to 147. What are we solving for? Exactly, we want to see QA, we want to see American Airlines choice. Okay, so solve for QA. This will give us the best response function for American Airlines for any, United quantity chosen. For any quantity that United chooses. Okay, so we have 339 minus, I'm going to take this to this side, and it's something for QA, so I'm going to take this to this side. QU minus 147 is equal to QA. 339 minus 147 minus QU, just rearranging some terms now, is equal to QA. Did I drop a term? Did I drop a term? I did. We have our 2 here. That happens, guys. It's just very important to check your numbers. No matter how much math fights against us, we will rage back. Okay, so we're going to divide both sides by 2 to be able to get QA by itself. So this would be equal to 192 minus QU over 2 is equal to QA. This, we can divide this a little bit further. So 96 minus QU over 2 is equal to QA. This right here is our best response function for American Airlines. We are partway through. Remember, to be able to complete and find the Cournot equilibrium, we need the best response function for both firms, and we're going to use that to find the Cournot. So we found it for one firm, and we can use that to find it for the other. The nice thing about, just a quick hint, the nice thing about symmetry like this, where they have the same demand function and cost function, is that, and they're solving this for Cournot, so simultaneous, same time choice, Cournot, UT. We can interchange the Q's. QU over 2 is equal to QA will be for American, and for United, it will be 96 minus QA over 2 is the best response for United. That's a quick side note. Now let's check to see if it's true. We're going to do the exact same thing again for United. Now do it. Do the calculation for United Airlines. Now we need marginal revenue for United, and we're going to set that equal to marginal cost for United. Okay, marginal revenue for United is total revenue for United, the derivative with respect to Q United, and the marginal cost for United is 147. Nice. Okay, so let's find that total revenue for United. This is P times Q United. Now the question is, what is P? P is equal to 339 minus big Q, or 339 minus QA minus QU. Now, note that I did not start with the residual demand here. If this was Stackelberg, we would definitely need to work with that residual demand. But with Cournot, calculations are a little easier, so we can skip that step of subtracting. Okay, I'll just write it. Where QU is equal to 339 minus P minus QA. Okay, that's very similar to what we did here, for American. Remember, we talked a little bit about the symmetry here. Okay. All right. So we have that the total revenue for United would be equal to 339 minus QA minus QU times QU. Okay, so this is equal to 339 QU minus QA QU minus QU squared. Total revenue for United Airlines. So marginal revenue for United Airlines would be 339 because this goes to 1 minus QA because this goes to 1 minus 2 times QU because this comes down here and we subtract 1. And so we can do our profit maximizing condition right here, profit max condition for United. So we have 339 minus QA minus 2 times QU is equal to 147. We're doing this for United, so we're going to solve for QU. Okay, and we want QU by itself. So we have 339 minus QA minus 2 times QU is equal to 147. I'm going to take this to the right-hand side and bring the 147 to the left. So we will have minus 147 is equal to 2 times QU. Divide both sides by 2, and we have 339 minus 147, just rearranging terms here, minus QA over 2 is equal to QU, just QU. So 192 minus QA over 2 is equal to QU. And so 96 minus QA over 2 is equal to QU. And like we said earlier, there is that wonderful symmetry where calculating this for doing this calculation right here. Doing this calculation for American gave us a glimpse into what United's answer would be. Best response function would be. Okay, so now we have the best response function, excuse me, sorry about all that scrolling. So now we have the best response function for United. We're going to combine these two to be able to, I'm going to make this bigger. So now combine both BR functions to solve for Cournot equilibrium. In other words, we're going to solve both equations simultaneously. Equations simultaneously. Okay, what does that look like? Our two equations are 96, so we have QA is equal to 96 minus QU over 2. This is the best response for American given whatever United does. And QU is equal to 96 minus QA over 2. This is the best response for United regardless of what American does or given what American does. Okay, so we're going to solve for QA and QU simultaneously. We have two unknowns, two equations, we can do that. All right, what does that look like? Well, we can either place what we've defined QA as in here, or we can place what we've defined QU as in here. Let's go with replacing QU. So we have solution solving for Cournot equilibrium. If we were to draw this visually, we would have, I'm going to talk really quickly about this. And this is QU, this is QA. We would have 1 excuse me, we would have 182. All I'm doing here is drawing the endpoints for these best response functions, okay, in 96. And here we would have 96. This would be this, okay, 96 and 182. Up here, we have the best response function for American. And down here, we have the best response function for United. Okay, remember endpoints is if, so for instance, if QA is equal to 0, what will QU be in that American's equation, and vice versa. All right, so let's go ahead and do the mathematical solving. Okay, so we're looking for this point when we solve simultaneously. This is our Cournot equilibrium. Okay. So we have that QA will be equal to 96 minus QA over 2 over 2. Okay? So this would be equal to 96 minus, let's bring out this half, 1 over 2 times 96 minus QA over 2. Okay. Don't forget this original QA. So what we're trying to do now is collect like terms. We want to get the A's, QA's, together on one side and the numbers on the other side so we can figure out what this optimal point is for QA. Okay, so we have that QA is equal to 96 minus, now we're going to apply this half to each of these terms, 96 over 2 minus to minus plus, okay, 1 over 2 times QA over 2, which is just QA over 4. Okay, so QA, I'm trying not to skip any steps here. So QA is equal to 96 minus 96 over 2 plus QA over 4. Okay, so negative times negative is positive. We're applying this negative 1/2 to each of the terms in the parentheses. All right, so we have QA is equal to 96 minus 48 plus QA over 4. We're going to collect like terms, so we're going to take this over to the left-hand side. So we have QA minus QA over 4 is equal to, what is 96 minus 48? 48, because half 48. I just told myself a joke there, but I couldn't actually vocalize it. Unfortunate. All right, so this will be equal to 3 over 4 because this is basically 4 over 4, right? And this is 1 over 4. 4 minus 1 is 3. QA, which is equal to 48. Again, we want QA by itself, so we're going to multiply both sides by 4 over 3. To get QA by itself, so we end up with QA, these two cross out, is equal to 192 divided by 3, which is 64. Therefore, we have that QA star, our Cournot equilibrium, is 64 units. This is the amount that the American produces at equilibrium, the point of stability between these two firms. 64. Okay, so now let's do this for United. We know how United is going to respond for whatever queue that, stop that. We know how United is going to respond for whatever queue that American chooses. And this is 96 minus, when I'm not making this equation up, we have that best response function for United. Okay, 96 minus QA over 2. So this would be equal, best response for United is 96 minus QA over 2. But we know that QA star, in fact, is 64. So we can figure out what United should respond with, which is 96 minus 64 over 2, which ends up being, you guessed right, 64 as well. Now, this happens because of the symmetry. In this equation or in this problem. 64. All right, so we figured out, up to this point, we have figured out the Q star for American Airlines is 64. The Q star for United Airlines is 64 as well. With these two, we can figure out the market quantity, which would be QA plus QU, which will be 64 plus 64, which is, what is that? 128 units. And with that, we can figure out price. That's right. Remember, price is equal to 339 minus Q. We got that from the demand function. So this would be 339 minus 128, which should be equal to $211. Beautiful. So we know in this market, they're going to sell or have 128,000 seats, because remember, this is in thousands. And each one-way flight is going to be 211, where 64,000 of those flights would be through United, and the other 64,000 will be through American. Now let's calculate the profit for American Airlines, given that they're producing, their Q is 64 and their P in the market is 211. Okay, remember the profit is equal to total revenue minus total cost. It's also price minus average total cost times quantity. And since we're looking at this for American, we're going to note that with A. Okay, so the profit for American Airlines, AAA, referring to the same thing in this case, will be equal to, well, our price is 211 minus our average cost is 147. If you're wondering where I got that from, remember earlier in this video when we introduced the example, I know we've done a lot of calculation, haven't we? It told us what the average cost is and that it's equal to the marginal cost. Okay, so going back down here to our profits calculation, we have P minus average cost, or average total cost, times our quantity of 64. This will be equal to $4,096. Again, because of symmetry, remember what symmetry means, this will also be the case for United because their market price, okay, symmetry means same cost function, same demand function. All right, now their market price is 211 as well. They also have that cost of 147 and they're also selling 64 units. So their profit is also $4,096. Okay, And we have come to the end of our calculation there. Good job staying towards the end.